Welcome to the Journey Shake Chem. Today's review for the assessment tomorrow. So please do the 2 warm-up questions to the best of your ability, and we'll discuss them in a moment. In number 1, we are using the colligative properties to determine various conditions for these compounds. And the first thing I must do, notice that they are all 1.0 molar solutions, so they all have the same concentration. Therefore, I must first write my formula for the compound and then dissociate it into its ions. Well, the first one is lithium iodide, and it forms lithium ions and iodide ions, not iodine, the diatomic molecule, but rather an ion because it's an ionic compound. The second one is iron 2 nitrate, and it separates into iron and nitrate ions. In the first case, we have 2 particles. In the second case, we have 3 particles. Sodium phosphate breaks up to give me 3 sodium ions and 1 phosphate. Remember that polyatomic ions stay together as units because they are sharing electrons. And in this case, we have 4 ions. Methanol is a non-electrolyte. This is not a base. It is a non-metal with what looks like a hydroxide, but it is actually an organic alcohol. And therefore, it only forms 1 particle. It does not dissociate. And the first question is, which one has the highest freezing point? So I first write that freezing point goes down the more particles I add. Vapor pressure also goes down the more particles that I add, and boiling point goes up the more particles I add. So boiling point is the one that goes up. Well, the one with the highest freezing point would be methanol because it has the least number of particles. As I add particles, the freezing point goes down. In the second case, I want the lowest vapor pressure, and the vapor pressure goes down the more particles I have, and therefore the lowest vapor pressure would be my sodium phosphate. The lowest boiling point would be the one with the least number of particles because boiling point goes up the more particles I have, and therefore that would be my methanol. Finally, the highest boiling point would be the one with the most particles, and that would be sodium phosphate. And you can see that it's either the one with the least particles or the most particles is going to be what the answers are. The only way to get to these would be to specifically ask which one forms 3 particles. And that's how you do number 1. We've had this type of problem many times. Well, we're figuring out the boiling point and the freezing point of a solution that has 16 grams of calcium chloride in 250 milliliters of water. I must change my grams to moles because my formula for the change in the temperature of the freezing point and the change in the temperature of the boiling point is molality times the constant times the number of particles. Therefore, I must change my grams to moles, and the formula weight of the calcium chloride is 111.1. We have 1 calcium and 2 chlorines to give me that number. And I change my grams to moles and I get 0.1440 moles of the calcium chloride. That is my solute. And I divide it by my kilogram of solvent. And 1 milliliter is equal to 1 gram for water. That is the density of water. And I get 0.25 kilograms. Well, when I multiply this out, I get a molality of 0.5760 molal. And then I apply it to my equation. And therefore, my molality is 0.5760. My constant for the freezing point depression is 1.86 degrees Celsius per molal, and I have 3 particles because calcium chloride, I should say, will dissociate to give me calcium ions and 2 chloride ions. And therefore, I have a total of 3 particles. And my constant for freezing is here, and therefore my change in the freezing point is 3.2140 degrees Celsius. And water normally freezes at 0, and I'm going to lower the freezing point, and therefore we have 0 degrees Celsius minus 3.2140 degrees Celsius. My new freezing point is minus 3.2140. Then for freezing point, I want normal significant digit rules, and the least number given in the problem is 3. And therefore, my final answer is minus 3.21 degrees Celsius. And then for the boiling point, I use the same molality, but I have a different constant for boiling. The boiling point elevation constant for water is 0.512 degrees Celsius per mole. And we still have 3 particles. And therefore, my change in the boiling point is 0.8847 degrees Celsius. Well, water normally boils at 100 degrees Celsius when you're at sea level, and boiling point goes up. And therefore, I add 0.8847, and I get 100.8847. And then boiling point has a special rule. We take it 3 places past the decimal and round it. And therefore, my final answer for boiling is 100.885 degrees Celsius. And that's how I do those types of problems. So that's been lots of practice. Well, the assessment that we have tomorrow, 60% of it is problems where you work them out. And I believe we've discussed how those work. And you had a quiz and solutions, and part of the test on, part of the assessment on solutions was also this format where 5 points each for calculations, and then 40% of it is based on understanding the terms and questions very similar to what we had in number 1. I know you do well. You always do well, and I can't wait to see you tomorrow. Bye.